Cold doesn't kill because it feels uncomfortable. It kills when your body begins losing heat faster than it can replace it. And tonight, somewhere in Ice Age Europe, that is the problem facing this small group of Neanderthals. Outside, the temperature is falling, the wind is strengthening, and their fire is beginning to die. We don't know these people's names. We don't know exactly how they divided their work, and we certainly don't know what they said to one another. But archaeological sites across Europe have preserved enough evidence for us to reconstruct the problem they faced. Because surviving a winter night like this required much more than being tough. There was no furnace, no insulated house, no synthetic clothing, no waterproof jacket, no box of matches. And if the fire went out, they couldn't simply turn it back on. Yet Neanderthals repeatedly occupied cold environments across Europe for hundreds of thousands of years. So something was working. Their anatomy helped. Their technology helped, fire helped, shelter helped, food helped, and the people around them helped. Individually, none of these solved the problem. Together, they created something surprisingly sophisticated, an entire system for managing heat. Tonight we're going to reconstruct that system piece by piece and find out how Neanderthals survived Ice Age Europe without freezing. Evolution gave Neanderthals cold-adapted bodies, but there's a problem. A cold-adapted body is not a magic shield against hypothermia. Expose that body to enough wind, enough cold, or enough time, and eventually the numbers turn against it. Staying warm costs energy. The body itself is a furnace, and that furnace needs fuel. But before our group can eat, they have another furnace to worry about. We've become so accustomed to seeing Neanderthals around campfires that we rarely ask the obvious question. How did they start one? Controlling an existing fire and producing fire on demand are not the same technology. For years, archaeologists debated how reliably Neanderthals could actually create fire. Then researchers started looking at their tools differently. A 2018 study examined microscopic wear on Neanderthal bifaces from France. Researchers experimentally struck similar stone tools against pyrite. The action produced sparks, and it also produced wear patterns resembling traces found on archaeological specimens. The authors argued that some Neanderthals were using bifaces as part of a deliberate fire-making system. But producing a spark isn't the same as producing a fire. The spark has to catch something. That material has to become an ember. The ember has to ignite fine fuel, and the fine fuel has to ignite larger fuel. Miss one step, and you're still cold. Which brings us to one of the strangest substances in the Neanderthal toolkit. At Pech de la Zay 1 in southwestern France, archaeologists recovered hundreds of pieces of black manganese-rich material. Researchers found evidence suggesting Neanderthals weren't simply picking up whatever black rocks they encountered. They appear to have deliberately selected material rich in manganese dioxide. Why? Experiments revealed an extraordinary property. In laboratory experiments, powdered manganese dioxide mixed with wood lowered the temperature at which combustion could begin by around 212 degrees Fahrenheit, while also accelerating char combustion. Neanderthals didn't need to know the chemistry. They didn't need the words manganese dioxide. They only needed to observe. This black material makes fire easier. And that is technology, observation, experimentation, memory, repetition, and presumably knowledge passed from one person to another. Our family's first problem is solved. They have heat. But now they've created another problem: smoke. Put a fire outside and smoke disappears into the atmosphere. Put one inside a confined space, and suddenly location matters. Too much smoke can make the shelter unusable. Move the hearth, and you change where people can sit, work, and sleep. You change light. You change radiant heat. You change airflow. So where Neanderthals put their fires mattered. At some Neanderthal sites, hearths and artifacts show that living spaces were not random piles of debris. At Oscurasciuto rock shelter in southern Italy, for example, archaeologists identified repeated spatial patterns separating hearths, activity areas, and other parts of the occupied shelter. People were organizing space around fire. They didn't need equations describing convection. They needed experience. Put the fire here. You can breathe. Put it there. Maybe you can't. That is thermal management in its most basic form. But fire alone still doesn't solve our problem, because most of the heat from a campfire never enters the human body, and our Neanderthals still have to stop the heat already inside them from escaping. This is where archaeology runs into a frustrating problem. Stone survives beautifully, skin does not. After tens of thousands of years, a stone scraper can still be sitting exactly where somebody dropped it. The hide it worked is usually gone. That means we know far less about Neanderthal clothing than we'd like. There is good reason to think animal hides were an important technological buffer against cold. We also have evidence of sophisticated hide working, but we do not have a preserved Neanderthal winter coat. We cannot say exactly how many layers they wore. We cannot confidently reconstruct every fastening, and we should be cautious about portraying them in perfectly tailored fur parkas. What we can reconstruct is the physics. Animal fur traps air. Air is a poor conductor of heat. Hold relatively still air close to warm skin, and heat loss slows. Add another insulating layer, and you can reduce it further. Suddenly, the animal you've hunted isn't merely food. Its meat provides metabolic energy. Its hide reduces heat loss. Its tendons and other tissues potentially provide raw materials. Its bones can become tools. One animal becomes part of an entire survival system. Here's where we need to destroy one of the most persistent images of Neanderthal life. They were not simply cave people. Neanderthals also occupied open-air sites and rock shelters. Caves dominate our imagination partly because caves are extremely good at preserving archaeology. But when caves and rock shelters were available, they offered something enormously valuable: protection, not necessarily warmth in the way a heated house is warm. Deep caves can be cold, damp, and dark, but shelter from precipitation and wind changes the thermal equation. Now our system has three technological layers: insulation, shelter, and fire, but the fire has been burning for hours. Every fire has a cost. Fuel. Someone has to find it. Someone has to gather it. Someone has to carry it. And if you want a fire through a long winter night, you need enough fuel before darkness makes gathering more difficult. That makes Neanderthal heat management an energy budget. Wood enters the fire. Chemical energy becomes heat. Food enters the body. Chemical energy becomes movement and heat. Two furnaces, one outside the body, one inside it, both require fuel, and the colder the environment becomes, the more important that energy balance becomes. This changes the way we should think about hunting. Food wasn't simply protection against starvation. Food was heat. Every calorie metabolized inside the body helped keep that body's temperature within the narrow range required for life. And that means failure to find food during a severe cold period created two problems simultaneously: hunger and reduced capacity to defend against cold. But there's another resource in this shelter that doesn't appear in any archaeological inventory, and it may be the most important one of all: other Neanderthals. Imagine trying to maintain this entire system alone. Find food, gather fuel, maintain tools, process hides, keep the fire alive, protect yourself, sleep, and then do it again tomorrow. Now add an injury, or illness, or a child. The mathematics become brutal. A group changes the equation. We cannot know exactly who performed which tasks in a particular Neanderthal family. But cooperation allows labor to be distributed. A shared fire warms more than one person. A shelter protects more than one body. Fuel gathered by one individual can benefit everyone. Food acquired by successful hunters can be shared. And perhaps most importantly, knowledge doesn't have to be rediscovered every generation. Neanderthals didn't need to understand thermodynamics. They didn't need to know that manganese dioxide was changing combustion chemistry. They didn't need a scientific theory explaining why a compact body loses heat differently from a slender one. They learned what worked, and they repeated it. Generation after generation after generation. If you enjoyed looking beyond the stereotype and into the evidence, subscribe to New Perspective. Because the closer we look at the people who came before us, the more complicated and more human their story becomes.